to Python lecture, guys, and in this lecture we are going to talk about left shift and right shift operators. So let's try to understand what is the meaning of left shift and right shift operator. We have already talked about a lot of operator in our previous lectures, so in this lecture let's try to understand even this particular part. So here is my screen, and yes, so let me try to type something over here. So let's suppose if I'm typing this one, and then if I'm going to write 2, so what will happen and what kind of a outcome it is going to give it to me. So it is giving me 20. So how it is giving me 20, let's try to understand. So this is called as shift operator, right? So I'm trying to use a left shift operator over here. Now what this left shift operator is going to do, so it is going to shift a bit on a left hand side by this many number of unit. If I'm going to place maybe something else, so by that number of unit it is going to shift the entire number. So I'll try to explain you with the help of example. So here let's suppose if I'm going to write bin, so I'm just trying to find out the binary of this 5. Yes, so binary of this 5 is what? 101. Okay, fine. So binary of this 5 is 101. Let me extract my pen over here so that I can explain by drawing something for all of you. So here, let's suppose we have binary of 5 is equals to what? So binary of 5 is basically 101, and here 2 is given to us, right? So binary of 5 is basically 101, and 2 is already given to us over here. So what I will do is I'll try to shift this entire number by 2 bit. Yes, I'll try to shift a number by 2 bit. This is the meaning of this particular 2. So if I'm going to shift this number by 2 bit, what will be the new number? On a left hand side, obviously this is a left shift operator, so on a left hand side, so I'll try to shift this particular number. So if I'm going to shift this number, it is going to be this one, right? On left hand side I'm trying to shift it, so there will be 2 placeholder. I'll just try to replace it with 0. So this is the number that I will be able to get. Now if you are going to convert this particular number into its decimal equivalent, so how I can convert it? So int, and then I can try to write 101 and then 00. Yes, and base is equals to what? Base is equals to 2. Now you will be able to get 20. So I'm just trying to shift a number on a left hand side, and then whatever outcome it is going to give, I've just converted it back into a decimal equivalent, and this is what it does. Now I'll try to show you a couple of more example, guys, so just be with me for a couple of more minutes with this video. Okay, so here we have 5 and we have left shifted by 2 unit. I can even write in this way. Let's suppose I have this number, and then I can try to even left shift by 3, by 4, by 5, by 6, by 8, whatever that I want. I can just do it, right? I can just do it. So here 123, I'm just trying to shift it, right? By how many units? 3 units. So here, what is the binary of 123? So binary of 123 is basically this much, right? Binary of 123 is this much. Now if I have to write it down, so binary of 123 is basically 1111, then 011. This is the binary of 123. I'm just trying to shift it, right, by 2 units. So obviously or by 3 unit. I'm trying to shift it by 3 units. So I'll try to place 30 over here. That's completely fine. So this number will become this one. And let's suppose if I'm going to convert this number, this particular number, into its decimal equivalent. So what I have to write? int, and then so 1111, then 011, 000, and base is equals to 2 over here, 984, and 984 is the number that I'm able to receive. So it's not at all a rocket science. It's a very easy one. So whenever someone is saying right shift operator and a left shift operator, so simple, shift it on left hand side. If it is a right shift it on a right hand side. That's it. So let me show you the right shift operator, guys, now. So right shift operator. Okay, fine. So just a reverse of left shift, you will be able to find out a right shift. Let's suppose I'm writing this 5, and then this, and then 2. Now it became 1. How it became 1? Let me show you that. So here, what I will do is I'll try to find out a binary of 5 first of all. So binary of 5 is what? Binary of 5 is 101. Okay, binary of 5 is 101. Okay, so binary of 5 is basically 101, and then this is basically a right shift operator. It will try to shift in a right hand side. Yes, on a right hand side. On a right hand side, it will keep on shifting it. So if we are going to shift this one right hand side by 2 unit, yes, by 2 unit if we are going to shift, so this will be gone, this will be gone, because on right hand side there is nothing. On left hand side if we are shifting, it will be replaced with the 0. But on the right hand side if we are going to shift, there will be nothing. So what will be left? Only 1 will be left. If you are going to convert 1 into decimal equivalent, you will be able to get 1. So we are able to get this particular result. If I'm going to, so it's just a reverse of left shift that we have done, nothing much. Yes. Okay. So here if I'm going to write same with a 3, right? So I'm shifting a bit by 3 units, so it is going to be a 0, because everything will be gone, 101, right? So I'm just shifting a 3 unit. If I'm going to write maybe 30 over here, doesn't make any differences at all, because all the digits are already gone on the right hand side, and it became null and void basically for me. So in this way you will be able to like implement a right shift operation and a left shift operation. Majority of time these operations are required for a multiple mathematical evaluation and algorithmic building. But yes, in general, so you will not be able to use this left shift and right shift on a regular basis, on a day-to-day basis. But yeah, occasionally, obviously, you all are going to use it while developing your own algorithm for some specific purposes. With that, thank you so much, everyone. See you again in my next lecture.